So yeah, I'm going to talk about the first part, how we're going to turn invoices into crypto-native assets, into NFTs. A little bit about myself. I'm one of the co-founders of Centrifuge. I've been based in New York and just recently moved to Berlin, which I'm very happy about. So hello, everyone. I've been working on, with our engineering team, on this first version that, as Leah said, we released today. So if you have any questions, reach out to me. Check on Twitter, and most importantly on GitHub. All of the stuff you'll see today is actually exists for you to check out and play around with. But before that, a quick introduction to Centrifuge. As Leah mentioned, we are building an open and decentralized network for the supply chain. So what we mean by that is we deal with documents like purchase orders, invoices, delivery notes, payment notes, refunds, all of these things. So how businesses interact with each other, how they purchase goods, define prices, agree on payment terms, and then ultimately settle these orders. We have a two-layered approach. There's a public blockchain part. We are built on Ethereum. This is where our identities are. And then we have a peer-to-peer network based on the P2P, where we do the heavy lifting. So looking at those two layers, we have, as I mentioned, on Ethereum, Ethereum is known as a public blockchain, so everything is publicly readable. It has a global consensus. This means that it's very expensive, but also very secure. It also has this advantage of all these on-chain standards, such as NFTs. So we use this for our identities, for committing to these states, which is what we call anchors, and then for minting these NFTs, which allows you to then access this ecosystem and use and leverage what other projects are building on top of Ethereum. Off-chain, we do the heavy lifting. So it's scalable, it's private, so you don't need to reveal anything. It's where we send these documents back and forth. A very quick overview. As I mentioned, so let's say Alice and Bob want to interact. They go on Ethereum, check the identity of Bob. Let's say Alice wants to talk to Bob, so she gets Bob's public key, then uses the peer-to-peer network to find Bob in this distributed hash table, verifies that Bob actually is who he claims to be by checking that he owns the private key to this public key, and then she has a secure channel to talk to Bob and transact. When a state is updated, so an example, an invoice is sent, and an invoice has been received by your counterparty, what we do is we hash this state and we commit to it on chain so that you have a verifiable record of what happened. To go a bit into detail about what this state commitment is, I first want to give a very quick explanation about Merkle trees. For those of you that are not familiar, Merkle trees are probably powering every single blockchain out there. I've not heard of one that is not using them in one way or another. They're really known to be an excellent data structure for making very efficient proofs about memberships in a set. So in a blockchain, for example, you have a Merkle root that you can use to prove that your transaction was included in a block. So each block would have a Merkle root of transactions. This is a tree with each leaf being a transaction, and then you say, okay, my transaction was mined, here's the proof. We do actually something slightly differently. Instead of using it just to prove membership in a set, we construct these trees in a way that allows you to create proofs about certain fields of an invoice. So if you think of, instead of putting a bunch of invoices into leaves and then having a Merkle tree with a list of invoices, actually each individual invoice is its Merkle tree and the fields are the leaves. So instead of being able to prove that a transaction is included, you can actually prove that the amount of the invoice is here $1,500 without having to reveal what those other leaves are. You do this by just providing the hashes that you need to get to this Merkle root. This is what we call precise proofs. So we take this structured data, this information, we turn this into a Merkle root, or we turn this into a Merkle tree, and the root of which we take, and this is actually what we anchor on chain. So we get this attribute of being able to share only parts of this document. So if you want to go to a bank and you want to prove that you have an invoice of amount X without revealing what you're selling, what the line items are, you could do that. So but now we have these off-chain assets, and we want on-chain tokens, so we can go and finance this invoice on Ethereum. Like the vast majority of assets are actually not crypto native today, right? What I explained, like invoices, it would be very hard to take a 2 kilobyte document and try to cram it into an Ethereum transaction and make this a smart contract. There are other examples like property titles that are just very big, where it would be very expensive to actually put this on chain. There are things that you don't want to put on chain because of privacy reasons, like your medical bills or whatever else. So we still need a way to get these on chain, but we can't because of privacy and because of scalability. So I want to use our example of tokenizing an invoice to get on-chain funding to explain how we've been working on solving this challenge for Centrifuge. I've mentioned our Anchor registry, which has these stake commitments. And now we have this NFT registry. So maybe a few steps back for people that are not familiar with NFTs. An NFT on Ethereum is a non-fungible token. It is a uniquely identifiable asset. Unlike an ERC20 token, an NFT is unique. It's not interchangeable with another token. That's the non-fungible part. So you have a serial number that has an owner in this registry. So what we do is, well, we want to sell this payment obligation. You want to say, instead of me, the supplier, receiving, or Kreuzberg Co-op receiving the money from Berlin Airport, we want to give that revenue that comes from Berlin Airport to a funder, and so that Kreuzberg Co-op can get the money now instead of waiting until that invoice becomes due and Berlin Airport finally pays. So to do that, Kreuzberg Co-op goes to this NFT registry that is our payment obligation. You submit proofs to this payment obligation, and you create and that payment obligation contract can check the anchor and ensure that whatever was exchanged in private on the peer-to-peer layer, so the actual terms of the invoice, that this is something that exists. So how do we actually allow this to happen? On the code side, it looks very simple. You say you want to mint a token, you say who the owner should be, you say what the token identifier is, so this is this unique serial number, and then so this is where it starts to get tricky. You want to have your anchor, so you're saying this is the state root that I committed to, or sorry, this is the ID of the state root, this is the root itself, and then you provide a set of values to qualify that whatever you're minting, whatever is behind this Merkle root, is actually an invoice that you can qualify it, and you can make certain statements about it. So you have these values, the salts, that's just to make sure that you can't easily do a rainbow attack, but we can ignore that for now. And then you submit the Merkle proofs for the values that you want to verify. So for the payment obligation, you would want to verify, for example, that this invoice, this off-chain document, is actually an unpaid invoice, right? And not an invoice that has already been paid a long time ago. You want to check that no other payment obligation has been created for this NFT. You want to make sure that you want to maybe make sure that you can list publicly what the amount of this invoice is and what currency it is in, so that when someone wants to buy this invoice, they know, or when they buy the NFT, they know NFT is for an invoice with the amount of $1,500. And then what you want to make sure is, well, of course, only the supplier is allowed to mint this invoice, well, because the buyer actually doesn't own this payment obligation. It's the supplier that owns it. So we do a Merkle proof. So on the client side, so I have this document. I create a Merkle proof for these different items. Then submit this transaction where I point to the anchor that exists on Ethereum, and I say, look, this is the Merkle root that I have. These are the proofs that whatever is behind this Merkle tree, that this is what you want me to supply. So in our case, it's a valid invoice, et cetera, et cetera. And then the NFT registry would actually validate this transaction and would mint an NFT on behalf of the supplier. So this NFT registry, or the payment obligation registry, is of course only one of many potential registries we could build. We have actually an example registry contract that you could just take and make all sorts of different things out of. If you would want to have an NFT that signifies an invoice paid, for example, you could redeem it for some sort of loyalty reward. You could create an NFT registry for this. You could do purchase order financing if you would want to. If you have an NFT registry that can create a token that signifies the potential revenue from a purchase order. So all of this can happen based on these documents that are exchanged on this peer-to-peer network. So how do we fund this invoice? Now that the supplier, Kreuzberg Co-op, has an invoice and an NFT for that invoice that is the payment obligation, well, one example is using this ERC-721 token as collateral on Dharma. And so without taking too much from Sid's talk away, this is how we actually did this transaction last week. We have this payment obligation registry that I've just explained how it works, how it gets minted. But then once Kreuzberg Co-op has the asset, she creates this loan request. This is a Dharma debt order where she defines the term. So I need money for 30 days. I need a total of 1,000 ETH or DAI or whatever crypto it is that you would like to use. She then finds a funder that would be willing to fulfill this debt order. The funder takes it, says, I'm willing to fulfill this order on the Dharma contract. The Dharma contract now owns the NFT, basically because that's the collateral that was decided on. So the NFT gets transferred into the debt order contract, and until Kreuzberg Co-op returns the money on this debt order, the NFT is held. If Kreuzberg Co-op doesn't pay on time, then the funder gets the right to seize this asset, and then by that own the payment obligation, and then could go and collect on this money from the buyer or the supplier. This is just one example, right? You could do anything with this NFT. You can trade it on a decentralized exchange. Instead of just borrowing against it, you could just sell it to someone and never worry about having to return this money again, and then the new owner would have to make sure they would get paid. You could actually lock this NFT in a CDP on Maker to borrow again without any counterparty. You could take this NFT and securitize it and sell shares on a loan using something like SET, or you could go to a bank that you have an existing relationship with, and instead of relying on paperwork or some sort of XML data exchange, you could actually say, well, we're going to do our financial transactions by transferring these NFTs back and forth. And so you have this record of who owns the debt by using this NFT. As I mentioned before, there are other things you can do with the NFT. you can use an NFT that unlocks a certain good if once you paid an invoice. So if you pay an invoice, you get an NFT, and then with that you can unlock a certain feature. You can do finance purchase orders. You can mint tokens for multiple documents in sort of reputation points, for example. You really have an opportunity to do anything that you want to come up with based on this off-chain information. That's actually pretty much it. So before I hand over to Sid, who will talk about exactly then how the Dharma part of this decentralized finance ecosystem works, I just want to say quickly thank you. You can reach out to me if you have any questions. Check out the website. Also on GitHub, it's just Centrifuge if you want to look at the code. And I'll be open for questions later. Thank you.
Hello, everybody. My name is Sid. I work at Dharma. I'm a protocol specialist there, so I do everything from developer relations, integration support for all the teams building on Dharma, and also do protocol research on kind of the next future versions of what we're building and how we can extend the protocol. So today, so Philip gave an overview of Centrifuge and kind of what the actual integration looks like with Dharma. I'm going to back it up a little bit, just tell you a little bit more about what we're building and kind of where Centrifuge fits in and kind of our vision for what blockchain-based lending looks like. So Dharma is a protocol that allows you to borrow and lend tokens on blockchains like Ethereum. And at Dharma, we build infrastructure that makes it very easy to build lending businesses that leverage blockchain technology. And this is sort of the core infrastructure that helps you administer any sort of debt instrument that can be issued and traded, like in Centrifuge NFT invoice. So we're live and ready for production usage today. We've been live on the Ethereum mainnet since May of 2018. We've had 3 different venture-backed businesses that have launched on Dharma, 2 of which are what we call relayers. They're essentially like lending marketplaces where you can go borrow and actually like lend money. And the other application is a loan analytics tool called LoanScan. So I'm going to tell you a bit more about why we created Dharma and kind of like the vision for what we see the future look like. So in 2017, there's this like huge ICO craze, people sort of launching different tokenized assets to fund their projects, right? This is sort of the disruptive moment for venture capital and sort of people kind of raising alternative money through cryptocurrencies. But most of these sort of resemble kind of like the equity asset class. And if you kind of look at the global traditional markets for equity, they're about like $65 trillion. And the whole crypto market cap, maybe this is a wrong data point today. It's definitely not 500 billion. I didn't change that. But as an asset class, right? Like if you look at the global debt market, it's over $200 trillion. Most of our lives actually runs on debt. If you look at your mortgages, student loans, auto insurance and auto loans and so many other things of your life is actually funded by debt, and this asset class is massive. But today the global tokenized debt market cap is 0, and of course since we've been live that's changing, and tokens are radically sort of reshaping how capital is formed, and from actually issuing these assets to actually trading them, right? And it's inevitable that blockchains could be a piece of this and making these debt markets more efficient and more transparent. So I'd like to make the claim that very few people actually know how to build great lending businesses and understand blockchain technology. So we try to bridge this gap by creating this layer on Ethereum where you could virtually build any sort of credit-based application on top of Dharma, ranging from like decentralized lending exchanges to other types of debt products that are more complex. So Dharma is a framework that helps you to actually issue tokenized peer-to-peer loans that are easily tradable. We provide a mechanism to also service these loans on-chain through the smart contracts entirely in a peer-to-peer manner. And then also, finally, is the ability to actually package and securitize these loans and then resell them on like secondary markets. So Blockboard is actually one of the applications that first went live that's actually built on Dharma. And this is actually a lending marketplace and a relay on our ecosystem, where you today can go and actually request a loan for a certain crypto asset, or even go and fund a loan and then actually view the status of all the loans that you've invested or like requested. So what are the benefits of tokenized debt? So blockchain technology is still pretty nascent, and as it matures, we anticipate that a lot of the world's instruments, financial instruments, are going to be tokenized. And today, like the main reasons for sort of like people wanting to tokenize debt assets is primarily cost savings. Like all the intermediaries that are involved, from the creation of the asset to the servicing of an asset and how the debt asset's actually repaid, takes a lot of sort of middlemen and intermediaries to finance that asset. By tokenizing it and then using smart contracts, you can sort of create this more efficient, programmable system that's more transparent and virtually reduces all these costs by not needing to interact with these intermediaries. So what do I mean by that? So tokens are efficient, but how? So for one example, the smart contracts act as the custodian and they hold the collateral for any debt asset in a smart contract. The actual ownership is automatically mapped to the actual owner of the asset. So you have clear sort of trail of like who is creating the asset and who owns the debt and at a given time. And then you also have sort of self-custody. So there's no counterparty risk of someone taking away your actual principal or collateral. I mentioned that tokens are programmable. So the properties and benefits that we get from this is that it's easily insurable, because you can actually see the repayment status. And if there's any false claims, you can create insurance contracts that protect these debt assets. You can create automated market makers that just plug into the different APIs that are available, either through Dharma or any relayer that's actually being built. Like I mentioned, you can securitize these assets and then trade them on secondary markets. And you don't have to deal with any intermediary like a paying agent or an escrow agent or any other administrators that are involved in this process. Right? You can automate the entire process just by like using smart contracts, which is really cool. And also there's a common standard that is built across all these different assets. So it really helps different wallets, exchanges, and different applications to share a common standard without having to like rebuild a certain like legal framework for things. And this makes sure that we have this like unified credit market that follows these standards and makes it easier to trade these assets on different types of exchanges and different types of applications. I mentioned that tokens are radically transparent. So the Dharma debt tokens are also actually an NFT, and I'll get into like how that works and what the process looks like. But Dharma debt tokens essentially give the power for individual loans to actually sort of display some of the properties and make it more transparent from the existing traditional financial system, because you can view the current value of an asset, you can see the risk associated with it, you can see the status of the debt and how often it's being repaid, and actually if it's like successfully repaid or default and so on. And what you get by this is essentially, as you have different types of debt products that are built on Dharma, you can essentially create these analytics to see like what are the prevailing interest rates, what is the health of a certain sector. And you can actually see how the entire market is performing. And this, of course, based on the assertion that most of these assets will be tokenized in the future. And if they are using Dharma as the infrastructure, you'd be able to get all these unique properties that are very useful. And of course, as a result of transparency, you have more better data, more information symmetry, and then lesser fraud. So how does Dharma work? So I'm going to walk through just kind of like the core sort of actors and keepers in the protocol, and then go through like a flow of like what that looks like. So Dharma smart contracts are deployed on Ethereum. So Ethereum is sort of like layer one, and then Dharma is sort of like sitting on top. And then the first entity is, of course, the borrower looking to borrow capital, lenders looking to earn an interest by actually investing in loans. The underwriter is sort of this like actor that's responsible for originating loans, helping in negotiation of the actual terms, and also servicing the debt to make sure repayments are paid if in case the loan defaults. They're sort of kind of managing the risk of the asset and providing a risk rating for the different debts that they originate. And then finally, we have the relayer, essentially like a lending marketplace where borrowers and lenders can kind of discover each other. Because as I'll go through the flow, the actual debts are originated off-chain. They're like shared off-chain, but you need a place where people can discover each other. There needs to be a marketplace for users of Dharma to actually access these capital markets. So a relayer is essentially sort of the rails in which you would access these types of debt assets. And this is very functionally similar to the 0x protocol, if you're familiar with that. So it's like the decentralized exchange protocol. And we kind of use the same concept here. And also, one thing to note is that an underwriter, relayer, and a lender can all be combined into one entity. We just sort of classify them as different actors based on their actual function in the protocol. But you can build an application that combines sort of different players in the ecosystem. So I'm going to go through the flow now. So the first step, and this is kind of like from the standpoint of an actual borrower and what that flow looks like. So in this example, so sort of the first thing the borrower would do would go to an underwriter, and this could be like a online peer-to-peer lending platform, like a lending club that's integrated and built on Dharma. They would go to this like website and they would sign up and they would like actually like request an application for a loan. And then what they're doing in that process, they're actually like creating a open debt order, and this is essentially like a request for a loan that they're signing. And based on the terms that they get, they go to an underwriter and they get this like cryptographically signed order, which then sort of gets passed on to a relayer, which is essentially the lending marketplace. And the underwriter here is an optional component. We don't have any underwriters live on the Dharma network today, but essentially the underwriter is sort of responsible for providing and creating sort of like a standardized risk framework that helps the end lender to know actually how creditworthy this borrower is. So as the actual debt order flows, it lives on a sort of centralized order book that a relayer hosts. And the lender can go to the relayer, kind of sort of see all the available opportunities for them to invest. And then if they meet those requirements and they're satisfied by the actual criteria of the loan, they can go and fill it. And what this does is actually the lender signs sort of the debt order off-chain, and then that essentially triggers the Dharma smart contracts to do the magic, right? So what happens here? So the Dharma smart contracts in this process transfers the actual principal from the lender's wallet to the borrower's wallet. And in the next step, the actual collateral, if there's collateral as part of the agreement, transfers from the borrower's wallet to the Dharma smart contracts as escrow. And this is held in escrow until the actual loan is fully repaid. And then the third step here is the Dharma smart contract mints a non-fungible token that we call the Dharma debt token. Essentially represents the right to repayment to that particular debt asset. Because each loan is sort of uniquely identified by its own terms. So the lender actually receives this Dharma debt token, which they can then go resell or repackage as they wish. In Centrifuge's case, they sort of the actual financier of the invoice sort of gets this debt token representing that particular stake in that transaction. And then finally, the actual fees gets transferred to the underwriter and relayer. This essentially comes from the borrower's wallet. And this flow, by the way, can also be done in the reverse. So we actually are launching a new feature that allow you to create a loan offer as a lender as well. So you'd be able to create these open credit facilities, which is very interesting. So a borrower doesn't have to wait for a counterparty in order to actually fill their loan. They would be getting it instantly if they meet those requirements. So just to summarize what our actual tech stack looks like. So layer one, the actual contracts are built on the Ethereum blockchain. Dharma protocol is a set of like sort of modular contracts, and we have a set of developer APIs that plug into our smart contracts and define how these applications can be built. And then finally, we have sort of third-party ecosystem projects like Centrifuge that are built on top of Dharma. So Centrifuge, Blockboard, LoanScan, all these things would sort of fit on top of the protocol. So if you're a developer or an entrepreneur looking to maybe build something on Dharma or interested in just playing around with their developer tools, we have a comprehensive developer portal that we built with all of our documentation, starting kits that will make it easy for you to like spin up different types of applications on Dharma, and just like a lot of information about how Dharma works and what you can build today. We also sort of created the sandbox, and this is one thing to highlight. We have what we call a Dharma relayer kit that allows you to spin up a relayer in less than 5 minutes. And we sort of created a sandbox that makes it very easy to get started building on Dharma. And you could take this and deploy in mainnet and like immediately have business that's actually launched and potentially collecting fees from that. So with that, I'd like to thank you all for listening to my presentation. I just want to say thank you again. If you have any questions, Philip and I will be around. We're gonna. Oh, sorry, Lucas and I will be around. I always get that confused. Anyways, so Dharma is sort of one piece of the decentralized financial stack. There are a lot more different protocols, applications, wallet applications, and so on that are built. And together they comprise sort of the DeFi, what we call the decentralized finance, short for like DeFi, short for decentralized finance stack. And there's a lot of interesting applications that are being created. And just from like the last few months, there's been an explosion of interest in this space. So yeah, let's build a better financial system together. Thanks. Lucas, do you want to come up? Yeah.
Anyone wants to ask any questions?
About Dharma itself or about
Anything?
Dharma, Centrifuge, what we're doing as an integration.
Okay, guys, maybe I missed it, but if you have the invoice to future payment, the payment there is a chance that there would be no payment. And what would be in this case?
So for the invoice payment obligation NFT, I mean, there's different ways you can go about it. If you're willing to go and collect, you could use this payment obligation to try to collect on the supplier well, there's two ways. You can either make this payment obligation mean that the buyer now owes the NFT owner money, and the supplier is completely out of the picture, or you could actually make a payment obligation mean that the supplier still owes the money to the owner of the NFT and would just forward the payment. And depending on how you would structure that, and this can be this is basically part of how you define your NFT registry that mints these tokens, you would either go to the buyer or supplier and collect. And of course, yeah, that's the risk that you have when you're financing assets.
So if I understand that the collateral for the debt on Dharma can be like a void, yes? If the guy who have to pay to supplier wouldn't pay in future, yes?
Yeah.
And how this risk is covered?
How it's covered if the supplier doesn't, if the buyer doesn't pay?
Yes.
Well, you charge interest so that you can first of all make a profit off of your money, but also that you can cover potential non-payment. In general, there's a very low risk on invoices actually compared to other asset classes for non-payment. If you compare it to like consumer loans, for example, generally those are much worse.
Okay, and maybe it is natural to introduce some insurance to this system. What do you think about this approach?
I think it's great. I would say we've partnered with Hokodo to offer trade insurance in a similar way, but also I think Sid could probably say something about what underwriters could do in this scenario.
So there is an actor called the underwriter in Dharma, right? So Centrifuge themselves could potentially be an underwriter, or any of their partners could underwrite the actual buyers in this invoice factoring system, right? So underwriters is just a catch-all term for entities that are providing a risk assessment for the different beneficiaries and actors in that particular transaction. So, you can have an underwriter for invoice factoring, could have an underwriter for some crypto native debt or consumer loans and so on.
Okay, thank you.
Anything else? Yeah.
What type of metadata or data is publicly visible on the NFT that represents a payable debt obligation? Because what I'm seeing is, let's say many corporations and many communities start to use this. It would be possible to glean a lot of information about corporate operations, about internal finance, from being able to publicly view these NFTs on the blockchain. So I'm just wondering if there's a way to cloak certain types of data, or have you thought about that?
So on the NFT side, I would give a similar answer to what I said previously. You can have different registries require different kinds of public attributes on the NFT. So a supplier could actually decide to reveal a lot of information publicly if that means that they could get a better rate and they're willing to do that, or they can reveal less. And there's two ways we could address this, and this is where this is a bit looking into the future. You could use things like zero-knowledge proofs to actually have these Merkle proofs be done in secrecy. So the NFT registry would actually only validate a zero-knowledge proof that all of these conditions are met without having to reveal the details. So example, I could say there needs to be a valid buyer that has passed KYC, but I don't need to reveal who that is. And then what we can actually do is we can allow these entities. So, for example, if a funder wants to know more about this NFT, we can allow the funder to off-chain on the peer-to-peer protocol talk to the supplier and find out what those details are and verify that this is verify with the anchor that is committed on chain that this is the information that you would want. With the Dharma debt orders, do you have something?
So one thing I forgot to mention is the actual underlying debt obligations can be extended for different types of assets. So you would just introduce those parameters if you need to add them, right? And if you need to know sort of off-chain information, you could have an underwriter sort of provide that data, say on like IPFS and some of the hash that can be viewable by any sort of entity that accesses that information. But yes, in a nutshell, you would have separate loan templates that would include these parameters that are pertaining to that particular type of asset. Any other questions?
Well, in that case, thanks very much for coming all. We'll be around for a little bit, and I guess email Sid at Dharma Protocol. What's that?
Yes, if you need to reach us, I'm Sid at dharma.io. You can check out our website too. Yeah, thank you so much for coming.